To Mondays with Mike. I'm Mike. It's Monday. It's the last Monday of wintertime. So that's one good thing. It also is St. Patrick's Day. So happy St. Patrick's Day to all of you, Irish or otherwise. I actually am Irish. Let's see, my grandmother was Irish. She was an O'Neill, which is why my brother's name is Neil. So I'm about a quarter, maybe a little less than a quarter Irish, something like that. So I've definitely got that in me. Hope everybody is enjoying this wonderful weather we've been having. I mean, the only small issues we've had is with dust and kind of a hazy atmosphere. I know we saw it firsthand. I had kind of an extended weekend. I don't know if you all noticed. I was out Thursday and Friday, and then Saturday, Sunday, obviously. But we took one last road trip here to take like a final college, do a couple of final college visits, and so we're decided now. So, I've got 3 girls, and 2 of them are graduating from high school. So we're going to have 1 Aggie. We're going to have 1 Baylor Bear. So very, very proud. And it's like close enough. You know what I mean? I'm still going to be freaking out that they're that far away, but it's like 2-hour drive, 3-hour drive, basically from Houston, I can live with. Still working out all the details of how we're going to, get them home and all that, but just very, very extremely blessed and proud to have an Aggie and a Baylor Bear, nurse and an engineer, unless they change their mind. And we all change our minds, right? Sometimes change our minds. So let's talk about it. So we got a few things that I want to talk about today on Mondays with Mike. We have this terrible outbreak of severe weather and tornadoes that struck the United States Friday and Saturday. I want to talk about the incredible forecast from the National Weather Service and how it most undoubtedly saved lives. And talk about what's happening around Texas too, which is that we're seeing wildfires. We're seeing brush fires break out. Hopefully it doesn't get any worse before it gets better. So let's get into it, beginning with the fact that today you'll notice it's probably going to be a little bit hazy. We don't have any serious problems with air pollution today. We might have a little bit of ozone forming this afternoon, which happens on sunny days. Ozone is invisible, so when you do see haze, you're not seeing the ozone per se, but it does happen on days, where we do have conditions favorable for dust and haze and things like that, like we do today. As far as the forecast for St. Paddy's Day here, we've got temperatures rising to near 80 degrees this afternoon and then sinking back down to about 70 by this evening. Now, I did want to let you know, this is the other big thing we have going on. Allergies, okay? It is tree pollen. This is oak pollen season. You are going to have this for the next at least couple of weeks, maybe the next 2 or 3 weeks. It's going to be a big deal. At the same time, you have oak pollen. You also will have grass pollen starting to enter the picture too. So we've had the recent measurements from the city of Houston went from heavy levels of oak pollen to extremely heavy levels of oak pollen. Kind of gone from bad to worse for allergy sufferers. Of course, all of this is not pollution. It's it's nature. It happens every year. It's the way things have to be. But if you do, suffer from allergies, just make sure you have your medicine with you and, hopefully it works. Because there's going to be a lot of stuff blowing around out there, especially this week, because it looks like we're going to stay pretty windy again. All right, I want to talk about just an example. So on Friday, we had tornadoes. In fact, I believe that turned deadly. Kansas, Missouri, and then swept across this area that we sometimes refer to as Dixie Alley, as opposed to like Tornado Alley, which would be like your North Texas, Oklahoma, Kansas, Nebraska, that kind of area, Missouri. Most often falls under that category of Tornado Alley, but there really are other parts of the country, in particular, the Deep South, Mississippi, Alabama, sometimes Georgia, but those 2 places that get, just tremendously large tornadoes. I mean, we've had epic tornadoes, extremely deadly tornadoes around places like Paducah, Kentucky, around Nashville, where you don't think necessarily that that's Tornado Alley, but it definitely is. So this particular area, what I'm showing you right now, is a forecast from NOAA's Storm Prediction Center. The Storm Prediction Center is located up here in Norman, Oklahoma. So they're on the campus of University of Oklahoma. And they are tasked with doing things like issuing watches. So if there's a severe thunderstorm watch, that's issued by SPC. If there's a tornado watch, that's issued by SPC. They also do things like fire danger advisories, which we'll talk about here in a minute too. But in this case, this forecast was released on Friday afternoon, Friday noon. It was like around noontime on Friday. This came out. This was the forecast for Saturday. Okay, so I want you to see what it's showing us here. So we have all these different colors, and they range from the mint green kind of color, which is just the general thunderstorm risk area, and then it goes to number 1 through 5. So we reworded them. This is the wording from the Storm Prediction Center. They go marginal, slight, enhanced, moderate, and high. I made an executive decision a few years ago that we weren't going to use that terminology because, think about it. In moderate, if somebody says there's a moderate risk, would you be concerned? You'd be like, okay, moderate. But actually, moderate is extremely serious. Extremely serious. High risk is as high as it gets. You see where it says yellow slight risk? See, this is what prompted us to make this change, right? At least in TV and social media, is that where it says slight, the yellow area, that's actually a big deal. Like if we're under a slight risk for severe weather here in the Houston area, that's a pretty big deal. Slight risk for severe weather means we're probably going to have a lot of very heavy thunderstorms, probably some severe storms, maybe some hail, possibly even a tornado. So slight doesn't exactly convey that very well. I don't know why the Storm Prediction Center won't change this. I know that it's been brought up, but I think like a lot of government entities, things change very, very slowly. And you know what I mean? It's just the wheels turn very slowly. So what we've done is, and I think you'll see this in a lot of situations, we've just broken it down into like 1 through 5, with 1 being a slight chance, for a possibility for severe weather, all the way to 5, which is Armageddon. So anyway, what I wanted to show you is that the National Weather Service Storm Prediction Center had Mississippi and Alabama under that rare pink area, the high chance for severe weather, the high chance for seeing tornadoes, hail, damaging wind. This was more than 24 hours. In fact, this was like 30, 34 hours in advance of when all of the tornadoes eventually hit. So notice that highest risk area was right there, Mississippi, Alabama. Then there was a moderate risk area that went to Louisiana and stretched over to almost Atlanta, and then a much larger area that enveloped areas farther to the north. But when I show you where the tornadoes actually hit, I think you can get an appreciation of the incredible ability. Well, it goes all the way around. First of all, the ability and the value of the forecasters at the National Weather Service and their branch, the Storm Prediction Center, to highlight that area, and by the way, that was just the day before forecast. They had been forecasting that days in advance. But think about it, if you lived in that area, or let's say it happened here, right? We have the rodeo going on. If we knew 2 or 3 days ahead of time that we were in this high risk area for seeing tornadoes or something like that, then everybody would know. They would have to take steps of, okay, if the weather gets nasty, where's everybody going to go? You have to come up with contingency plans for keeping everybody safe. So it's really invaluable to everybody, not only if you're having big events outdoors, but just even amongst your own family. Say, hey, look, the Storm Prediction Center put us in this highest risk area that almost never happens. So if you find yourself in this area, you say, oh gosh, this is going to be really bad, right? But here's the thing, it was accurate. That's the most important part, is that there's no crying wolf, there's no the sky is falling. It turned out to be a nearly perfect forecast from the National Weather Service Storm Prediction Center, where you see these tornadoes popping up here, Mississippi, Alabama, right there. that was the area, right, where I showed you that pink, where it was the high risk area, and just a little bit more around it here, from Atlanta back over here to the north of New Orleans. That was the area that was under the, the next category down, which is still an extreme risk, but it goes like from a 5 to a 4. So that whole area, more than 24 hours ahead of time, they had pinpointed where these tornadoes were going to take place. Of course, it's completely impossible to narrow it down to towns and streets and things like that. But everybody in the path of these tornadoes, the emergency managers, the police, the firefighters, everybody knew that there was going to be a high risk for tornadoes that day. And the best part is, the most important part is that the forecast was accurate. Because the worst thing that could happen, is that there's this super high risk and tornado threat, and then nothing really materializes. That does happen sometimes, although it's happening less and less frequently. The National Weather Service receives these storm reports. Sometimes it turns out, see how they all form in a line like this? Sometimes that might have been just one tornado that kind of skipped around. And so that's why the storm survey teams go in there and take a look. So far, from what I'm seeing today, there's been at least one EF3, possibly 2 EF3s. So we're talking about, that's basically like the equivalent of getting hit by a Category 5 hurricane, an EF3. And remember, EF is Enhanced Fujita Scale, named for Ted Fujita, who was a pioneering severe weather meteorologist back in the 1950s. A lot of these that touched down also did touch down at night. The ones that were in Alabama were more just after sunset or as sun was setting. And of course, the nighttime ones are always a little scarier, right? The ones I believe that were here in Mississippi, Louisiana, were just a little bit earlier when the light was still out. But bottom line is that the forecast was pretty spectacular. And it really drives home the point of why the National Weather Service is so important, why NOAA is so important, National Oceanic and Atmospheric Administration. The Storm Prediction Center themselves, why they're so important. Let me just get up so I could read this, because we have a couple of these storm reports that came in. So here's Montgomery, Alabama, and located over here to the north of Selma, Alabama. This was one of the tornadoes, 2 fatalities and 2 people injured. So we lost 2 lives there, 2 people injured. An EF3 tornado confirmed in the Plantersville, not Plantersville, Texas, and not Dallas County, Texas. This is over here in Alabama. So that was one of the EF3s that came down. We had a live report from our Fox reporter, Sarah Allegre, who was here in Talladega County, Alabama this morning, here to the east of Birmingham. This one person died, 1 person was injured. That one was ruled an EF2 tornado in the Winterboro area of Talladega County. So, that's just 2 examples of many. Very scary stuff. I think, you like to think that a lot of lives were saved, though, because everybody knew that it was coming. I think what you'll find is that as the forecast models get more and more powerful, and we'll probably begin to work in some of that AI, like ChatGPT, the whole artificial intelligence type of thing, where computers are going to be able to learn from a big data set of looking at radar and then being able to teach it when a tornado occurred. And that's, I think, going to be a big help for forecasters also to make the forecast even better over the next couple of years. I think you're going to find that a lot of, look, we're still going to get the forecast wrong sometimes. I mean, the atmosphere is an unpredictable kind of thing, but I think that the models are getting really, really, really good. And the forecasters at the Storm Prediction Center are getting really good at highlighting areas to give you as much warning as possible that severe weather is going to be taking place. So what are the basics of what causes tornadoes like this? Anytime you see a diagram, it's kind of like when we were in school. Regardless of what you're being taught in school, everything that you're being taught is like this idealized version. Nothing is usually as simple as it's shown, but it gives you the idea, right? So we have wind that flows in different directions at different speeds when you go up and down in the atmosphere. For example, here in Houston today, the wind at the surface is coming in from the southeast, and the wind way up in the atmosphere is like coming in from the west. So that's a turning with height. We call that wind shear. So in this case, this example, you have winds that are blowing from right to left at the bottom of your screen and from left to right at the top of your screen. So that would be more like the mid-levels and jet stream layer. So in between the two, you have turbulence that forms. You have some rotation that starts to occur. Now, you've probably, if you've flown on an airplane, you've experienced this before, that when the plane has to fly through these areas of turbulence, you're getting shifting winds and changing winds, and so the plane is really bouncing around. So pilots try to avoid this, but sometimes you can't. So you start to get this rotation happening in the middle part of the atmosphere, like the lower middle part of the atmosphere. Again, this is an idealized presentation. It doesn't always happen perfectly like this. Then it sort of gets turned on its side as you get these updrafts that are occurring in the rotating thunderstorm, which is called a supercell thunderstorm. And then instead of rotating this way, it kind of gets turned, and that rotation turns into a tornado. They come in different sizes. They come in different shapes. Sometimes that rotation that starts off like this doesn't just perfectly, like this model shows, just all of a sudden upright itself, which is why you'll have these twisty rope kind of tornadoes and real skinny ones. And sometimes you'll have ones that come together perfectly, which form these giant, just frightening wedge tornadoes. And so in this case, we've seen the wind shear that I pointed out forms a tornado like this. There are a lot of variables, though, that make this difficult. For example, rain. Around here, it's rare that we'll see tornadoes because the vast majority of the time, and I think probably applies to these ones that just hit Alabama and Mississippi as well, is they are called rain wrapped. So imagine if this whole thing was obscured. You couldn't see it because it's just raining cats and dogs. It's just raining like crazy. And so you hear the wind picking up, and maybe you hear your weather radio, or hopefully your weather app, like your Fox 26 app, start dinging, going off, saying there's a tornado warning. But if you look out the window, you probably will not be able to see anything because they are wrapped in rain. A lot of the ones like from North Texas and Oklahoma and Kansas, there's a lot more dry air near the surface, and you can kind of see the tornadoes from far away. And plus there's no, if you're in an area that's rural. But a lot of the southern United States ones are not like that because there's a lot more humidity. What we look for on radar, and you've probably heard this, is this concept called a hook echo. And a lot of times we will look for certain features on the radar image that catch our attention and say, whoa, that looks like a tornado. And we have a lot of tools to do that, but this is the basics of it, is that you have, the rotation is counterclockwise of the vast majority of tornadoes. There are clockwise tornadoes that happen. Most of the time they're short-lived and small. Sometimes they'll even form in pairs, and one of them will kind of die out, and then the counterclockwise one will win out. But you can sometimes spot what's called a debris ball on radar. It's like this bright area of reflectivity that's not actually rain or hail, but it's like pieces of debris, pieces of trees, and God only knows what else. We also have this elongated area that's the hail core, where a lot of times tornadoes are accompanied by hail. A lot of times the hail will come before the tornado. Depends on what direction you're in, relative to the tornado. So we could look at things like all of a sudden bright colors here, like where you get the highest levels of what we call reflectivity, where it kind of turns black like that, indicating that there might be hail in those locations. And then there's like a weak area too, that sometimes the tornado can actually be like, you get this weak region here where it switches over from hail to all of a sudden no reflectivity there. And it's called a weak echo region. And that a lot of times is associated with rotating thunderstorms and where the tornado is going to form as well. So we do have a lot of tools to show us now where these features are going to be on a thunderstorm on radar that we didn't really have before. We had what's called dual pole radar, which we've had here at the station for almost 20 years. The leading edge, which we call the gust front, that's that whoosh of cold air that all of a sudden, when you're standing outside and all of a sudden, it's like was hot out, and then all of a sudden it's like whoosh, you get that gust of wind. You say, okay, there's a storm coming. It's almost like a feeling. You get this feeling. That's the gust front that comes through. And then behind it is when it'll start to rain and sometimes start to hail. And then, when the worst of circumstances, it actually turns over and becomes a tornado. Switching gears, I want to talk about something that's going to be affecting Texas here, not necessarily severe weather, but different kind of severe weather. And by the way, something else that's handled by the Storm Prediction Center. We're talking about fire weather. So when we talk about fires, I know, you might think, well, gosh, are we talking about like house fires and buildings on fire? Sometimes, yes, but we're talking mostly about vegetation. So you have grasses, you have, marshy areas, you have forested areas, you've got kind of like desert, sort of a grass. It's extremely dry right now. Of course, the desert's always dry, but we're especially dry right now because much of the state of Texas is under a drought. We're not really under a drought here in the Houston area. We are starting to dry out a little bit. There are some spots near the beaches and other spots to the west of Houston that are slipping back into drought territory. But in Houston proper, we're not. Thing is, out to our west, we're starting to see some fires form. In fact, there is a fire that is burning right now, depending on when you're watching this. But as of today, Monday, the 17th, there is a 9,500 acre wildfire that is burning in the Texas Hill Country near Fredericksburg, Texas, which a lot of you are familiar with. It's out there. It's the vineyard areas, out there to the west of Austin. 9,500 acres. And it is about 55% contained, although I'm sure they'll get a hold of it a little bit more. So it's here to the north of San Antonio and to the west of Austin. It's called the Crabapple fire. And by the way, these fire names are usually just named for what they're either a town that they're near or a park that they're near or some landmark that they're near. So, gosh, like in California, that the Eaton fire, remember? And there was a campfire. I mean, it's like different fires that are just named for where they're close to. So here there just happens to be a little town called Crabapple, and it's near Fredericksburg, and so that's why it's called the Crabapple fire. But it's going to have a plume coming out from it, of course, depending on wind direction. Today, that plume, which was kind of pointed in our direction, is going to start to push back off toward the north. But what I wanted to just alert you to is that we are probably going to have some of that smoke eventually mix its way through the state, and we'll probably notice it here as well. So this map is going to show us how the air is flowing around and humidity values. And so you look for this orange area, which is eventually going to be pushing from West Texas in our direction. So you'll see here, this is 11:30 a.m. on Wednesday, where we get this push of drier air that's coming in. The green is the more humid air, and that's going to be our brief chance for seeing rain on Wednesday. And then it'll be followed by much drier air coming in. And I think probably you can count on the fact that we're going to have some smoke. I don't think it's going to be a big deal, but we'll have some noticeable smoke or haze in the sky on Wednesday and Thursday. We may actually have the tree pollen pop, a little bit more coming in on that breeze from the northwest. And some dust is possible as well, because there's just a lot of stuff that's really floating around the air, a lot more so out there in central and north central Texas than it is here. And I think that'll get pushed in our direction too. So we're going to keep a close eye on air quality levels for you coming up for Wednesday, Thursday, Friday this week. But other than that, just enjoy a really nice forecast, because the week's weather does look really, really good for the most part. Next best chance for rain is going to arrive on Sunday, a little bit Wednesday, and then probably a better chance Sunday, Monday of next week. All right. I want to thank you so much for joining me here for Mondays with Mike. We've avoided the tornado threat, around here, but we're getting into that time of the year where we do see more frequent severe weather threats. And so we will be on top of it for you. Be sure to download the Fox 26 weather app so that if there's anything put into effect for your area, you will be informed about it forthwith. Shout out to my mom and Neil down in South Florida. Hope everybody's doing great, and I will see you next time.